Hi everyone, welcome back. This video contains demonstrations and discussions on practice exercises found in our modules. Specifically, this will be concerned on the practice exercise B of lesson 1 of our unit number 2. Practice exercise B will cover the multiplication law or the product rule and the division law or the quotient rule of exponents. So let me share to you again the material here. Okay. Our lesson number 1 is again review on laws of exponents. In the previous video, we were able to talk about the basic uh, interpretation on what is an exponentiation or an exponential notation. Right now, we are going to apply the first two rules, first two laws of exponents. So we are going to proceed immediately with practice exercise B. In practice exercise B, we only have three numbers. But these three different numbers here needs proper analysis in solving or simplifying the expressions. Okay, I have already placed these exercises in our in a paint application software wherein we can just scribble and place any of our important notes and concepts. Now, for number one, we have here, we need to simplify the expression. But before we go to simplifying any of these numbers, we need to understand that when using multiplication law and the division law of exponents, there is a great need for us to determine which of those expressions has the same basis. Because we can't apply multiplication law of exponent nor the division law of exponent if we deal with um, different deal with exponentiations with different bases. Okay, we could just, that is why we started with practice exercise A in determining what is the base, because here we really need to determine which of the expressions have the same basis. As for number one, we actually have same basis. Okay, all the bases of of this exponentiation are letter h or variable h. So we can just simply use and apply the um, multiplication law. Notice that in our given, we already have negative exponents. And I know that if you have been reading in advance, part of our module also talked about how do we deal with expressions with negative exponents. But before we go to that and before applying that, you can just simply apply multiplication law here. This will become in multiplication law, we simply copy the base, okay, because all of them has base h, and we proceed with adding the exponents. This is on multiplication law. We add the exponents. So we take 6 plus -2, and then plus the third variable here. Don't forget that it has an exponent 1. So plus 1, and then plus 3, and plus -4. This is made to this one because we all of the expressions, all of the exponentiations in number one have the same basis. And therefore, simply add the exponents. So 6 plus -2 is 4, plus 1 is 5, plus 3 is 8, plus -4, which is actually 4. So this is the answer for item number 1. The answer is 4. Are we really sure that it's 4? Let's check again. Okay, let's check again. Again is 6 minus 2 is 4, plus 1 is 5, plus 3 is 8, and then minus 4, we have actually here 4. So the answer for number 1 is h to the power of 4. As for number 2, we are still going to use the multiplication law here, but we need to understand that we have different exponentiations here. At the same time, we also included numerical coefficients. So let us copy this first. Let me copy this first here before I will give you the important points. Now, When we multiply these expressions, we separate the product of the numerical coefficients and the product of the literal coefficients. We all know that numerical coefficients are those constants that were placed in a term, and the literal coefficients are the variable. So for numerical coefficients, we just simply use the simple multiplication. As for the literal coefficients, we will now apply the different laws of exponents, specifically here, the multiplication law. So we start here with this expression. So you have 2 times 3, because these are the numerical coefficients, times 1. Don't forget that this third expression also has 1 here as numerical coefficient. Well, if you will multiply it by 1 or just simply do not place here 1, it will not matter because 1 multiplied to any number is the number itself. That's for the numerical coefficients. And then let's proceed to the literal coefficients. You have a to the power of 1 for the first term. Second has none. The third has 6. So we have plus 6. As for b, you have b squared, or b to the power of 2 plus, and the second term you have 1, no more. And finally, you have here a variable c. Again, we separate the product of the numerical coefficients and the product of the literal coefficients. As for the literal coefficients, again, you can only add the exponents of exponentiations with the same bases. Do not combine all bases into just one. Okay, so 2 times 3 times 1, this is 6. As for a, you have a to the power of 1 plus 6, which is 7. B to the power of 2 plus 1, which is a 3. And then you write here C. Right? So since uh, no more variable here can be combined using any other laws, this is our final answer. So again, what matters here is the proper determination of base and similar bases. As for number 3, this an item is a combination of both multiplication law and division law. First, we will apply the multiplication law on the numerator, okay? And then we will use the division law by simplifying whatever the result of the numerator and then its denominator. For some of you who can answer this immediately, and the answer may be correct, I don't mind as long as you're following the right processes and protocols. But for some of us who still, or whose our goal is actually to learn the processes and to master the processes, I would always suggest that you don't need to rush. Okay, you can do it step by step. So for number 3, we can actually again combine first the numerator. So we use the numerical coefficients. So you have negative 3 times 2. And then we combine the literal coefficients of the same base. You have k has exponent 1 plus the k here has exponent 7. And then m cubed plus 1. Okay? That is what will happen on the numerator. So we simply copy the denominator 6 k to the power of 4 m squared. Again, if you could answer it immediately, if you could combine it immediately, why not? You may do it. But again, what I'm doing here is the step-by-step demonstrations. So for the numerator, you have negative 6, the product of negative 3 and 2, k to the power of k to the power of 8, and m to the power of 4. All over 6 k to the power of 4 m squared. Okay? Now that we are done with simplifying the numerator, so we can now simplify the whole rational form by applying the division law. But of course, you can just simply simplify this numerical coefficient first. So we expect that our answer is negative 1. We simply place negative 1. And then you proceed with the division law. In a division law, instead of adding exponents of exponentiation with the same bases, you will subtract. Okay, and do not interchange the minuend and the subtrahend. The minuend should be the exponent of what is present in the numerator. The subtrahend is the exponent of what is present in the numerator. So you have k to the power of 8 minus 4, and then m to the power of 4 minus 2. Okay? So that is the processes that involves our literal coefficients. And finally, the final answer here, if you have negative 1, it, negative will do. Okay, because you can just simply uh, omit 1 because understandably it has a 1 coefficient, numerical coefficient. And then you have k to the power of 4 and m squared. This is our answer for number 3. Again, for numbers 1, 2, and 3, it covers the concepts of the division law and multiplication law of exponent. Okay, so for the next video, it will cover the next practice exercises covering different laws of exponents. So this is the content of this video. Hopefully you will use this video as part of your review and continue practicing and answering problems. That's all. Goodbye. See you next time.